What if I told you there's a hidden energy force enveloping our planet, one as fundamental as gravity and Earth's magnetic field, yet until recently remained just a theory? This force, called the ambipolar electric field, is a global energy phenomenon that plays a powerful role in shaping and sustaining Earth's atmosphere. For decades, scientists suspected its existence, but only with NASA's recent Endurance mission have we been able to measure it directly for the first time. From my perspective as a space scientist, the discovery of the ambipolar electric field is nothing short of revolutionary. This invisible energy field works silently but decisively to keep our planet habitable. It not only influences how charged particles behave in the upper atmosphere, but also creates what's known as the polar wind, a steady stream of plasma particles gently pushed away from Earth's poles into space. This process might sound like Earth is losing parts of its atmosphere, and in a way it is, but this delicate balance is crucial. The ambipolar field helps regulate atmospheric loss, protecting us from the harsh effects of solar radiation and space weather, and ultimately preserving the conditions needed for life to thrive. Stay with me as we explore this incredible unseen guardian of our atmosphere, a force that has quietly shaped our world for millions of years and continues to do so today. Have you ever wondered what invisible forces work tirelessly to shield our planet from the harshness of space? Earth is surrounded by powerful energy fields that silently protect life as we know it. Among these, the magnetic field acts as a mighty guardian, deflecting deadly solar radiation and cosmic rays that would otherwise bombard our atmosphere. Meanwhile, gravity firmly holds our atmosphere in place, preventing it from drifting off into space and playing a key role in regulating Earth's climate. But there's more to this cosmic ballet. Most of the universe is made up of plasma, a unique state of matter composed of charged, ionized particles. This plasma fuels breathtaking phenomena like the aurora borealis, painting the night skies with shimmering lights that have fascinated humans for millennia. Here on Earth, plasma exists high above us in the upper reaches of the atmosphere. What's truly fascinating is how this plasma is trapped and controlled. Our magnetic field creates a boundary called the plasma pause, which acts like an invisible fence, holding this charged plasma close to the planet and preventing it from escaping freely into space. This delicate interaction between plasma and magnetic fields is a key piece in understanding how Earth's atmosphere remains stable and life-friendly. Stay with me as we dive deeper into these invisible forces, the magnetic shield, the pull of gravity, and the dance of plasma that together create the protective cocoon around our world. What if I told you that a mysterious wind, flowing faster than sound, was quietly escaping from Earth's poles? A discovery that challenged everything we thought we knew about our planet's magnetic shield? Back in the 1960s, the first spacecraft flying over the North and South Poles detected this supersonic stream of charged particles, plasma, rushing into space. This wasn't just any wind. It was an invisible outflow that defied the prevailing theory that all magnetic field lines were closed, trapping these particles. Scientists realized something profound. Earth's magnetic field might have an open tail that allows plasma to escape, rather than a completely closed bubble. But the true puzzle lay in the temperature of these escaping particles. If solar energy alone caused atmospheric loss, we'd expect these particles to be heated, yet many were surprisingly cold, traveling at breakneck speeds. This led to a bold hypothesis. There must be an invisible, planet-wide electric field driving this so-called polar wind. Coined in 1968, the term marked a turning point, sparking decades of research. Back then, the technology wasn't sensitive enough to detect this weak electric potential, and the idea remained theoretical until now. As someone who's devoted their life to unlocking the universe's secrets, I find this story thrilling. It shows how a subtle, unseen force can have an outsized impact on our atmosphere, challenging our understanding and opening new doors to the mysteries of planetary science. Stay with me as we dive deeper into this incredible journey of discovery, where the whisper of the polar wind reveals Earth's hidden electric heartbeat. What if I told you that the fate of entire worlds hinges on the strength of an invisible electric field? While Earth's delicate ambipolar field quietly nurtures life, its neighbor Venus tells a starkly different story. Space Agency's Venus Express mission revealed an electric potential around Venus nearly 5 times stronger than what we expected, about 10 volts compared to Earth's mere 0.3 volts. This intense electric field likely acted like a cosmic vacuum, pulling positively charged ions, including oxygen, right out of Venus's atmosphere, draining its life-giving water over time. This dramatic contrast sparked a burning question for scientists. Does Earth have a similar electric field? And if so, how has it managed to hold on to its precious water? NASA's Endurance mission was born from this very mystery. They developed a sensitive instrument, a photoelectron spectrometer, capable of detecting Earth's faint electric potential by measuring electrons escaping our atmosphere. Launched from the Arctic's Svalbard rocket range, the mission soared above the magnetic North Pole in 2022, gathering data that finally confirmed our planet's ambipolar field subtle but vital. As someone deeply moved by the fragility and resilience of planets, this discovery feels like unlocking a hidden heartbeat of Earth itself. It's a reminder that even the faintest forces can tip the balance between a world teeming with life and one lost to the void. So stay with me as we explore how measuring this faint electric field opens a new chapter in understanding our planet's past, present, and future. What if I told you there's an electric force so subtle, yet so powerful? It silently shapes the very edge of our atmosphere and guards the delicate balance of life on Earth. Nestled within the vast expanse of the ionosphere, starting about 80 kilometers above us and stretching thousands of kilometers into space, lies the ambipolar electric field, a phenomenon that's been quietly influencing our planet for millions of years. This isn't just some abstract scientific concept. It's a living, breathing part of Earth's protective shield. The ionosphere itself is a layered realm where the sun's ultraviolet and X-ray radiation strip electrons from atoms, creating a sea of charged particles, ions, and electrons that dance under the influence of this electric field. Because electrons are thousands of times lighter than ions, they zip upward with incredible ease, while the heavier ions feel the tug of gravity pulling downward. But here's where the ambipolar field's magic happens. It forms a delicate tug-of-war, holding these particles together through an electric field that gently lifts ions upward, inflating our atmosphere and powering the mysterious polar wind. To me, this intricate balance is like the heartbeat of Earth's atmosphere, an unseen pulse that sustains the environment we depend on. Understanding how this electric field operates gives us not only insight into the present state of our atmosphere, but also clues about the evolutionary journey that has made Earth a haven for life. So stay with me as we dive deep into the remarkable structure and dynamics of the ambipolar field, an invisible force with an outsized impact on our world. What if I told you that every second, Earth quietly loses thousands of tiny particles to space? Yet this subtle loss is a sign of a powerful force at work. The ambipolar electric field is not just a passive player. It actively drives the escape of charged particles like hydrogen and helium from our atmosphere, sending about 3 kilograms of hydrogen and 50 grams of helium out into the cosmos every second. While these numbers might sound alarming, they're actually a testament to the delicate balance our planet maintains to sustain life. This gentle leak of atmospheric gases is part of a complex dance involving thermal escape and non-thermal processes like the polar wind powered by the ambipolar field. Despite the ongoing loss, Earth's atmosphere remains robust and stable, with oxygen expected to last for billions of years to come. But the story gets even more fascinating. This same electric field that nudges particles into space also shapes the density and structure of our atmosphere, keeping it thick enough at high altitudes to protect us from harmful radiation. As a space scientist, I'm deeply moved by how this invisible force quietly governs our planet's fate, balancing loss and protection in a cosmic tug-of-war. Understanding the ambipolar field's impact helps us appreciate just how remarkable Earth truly is, a sanctuary delicately held together by unseen, electrifying currents. Stay with me as we explore this invisible yet vital influence that shapes our atmosphere and life itself. What if I told you that unlocking the secrets of Earth's ambipolar electric field could reshape our understanding of not only our planet, but the entire cosmos? This invisible force, barely detectable yet profoundly influential, represents a gateway to countless discoveries about atmospheric dynamics, planetary evolution, and even the conditions for life beyond Earth. The recent measurements from NASA's Endurance mission mark just the beginning. With the first direct detection of the ambipolar field, scientists now have a tangible piece of the puzzle, one that invites deeper exploration into how this electric field interacts with solar winds, cosmic radiation, and Earth's magnetic environment. The implications extend far beyond academic curiosity. They hold keys to predicting space weather impacts, protecting satellites, and understanding how atmospheres evolve over billions of years. As a space scientist, I feel a profound excitement knowing that each new insight into the ambipolar field brings us closer to unveiling Earth's hidden heartbeat. It's a reminder that even the faintest forces have the power to shape worlds and sustain life. Join me as we look forward to future missions and research that will illuminate this mysterious electric field, guiding us toward a deeper grasp of our place in the universe. If you found this video helpful or interesting, don't forget to hit the like button to give me more motivation to create more videos. And please subscribe to the channel so you won't miss the latest and best content I'll be sharing soon. Thank you so much for being with me on this journey.